Okay, no, Good. Okay, so we'll talk about these 6 things: smart team, smart tier, smart QoS, smart partition, snapshot, and smart quota. Okay, before we go into all these things over here, okay, you might be confusing why there's some smart, there's no smart over here. Okay, so in Huawei, actually all these features here, some of the features here you need to buy the license, then only you can activate it. Without license, you can't activate it. Okay? You can't use this kind of feature. So most of the feature here need license. So in Huawei license, basically is to activate the software itself. Okay, is to activate the software itself. So what type of software do you have? So actually Huawei separate the software into 2 types: a smart and a hyper. Smart feature or hyper feature we call it. So smart, you can see smart team, smart tier, smart QoS. Then there's another feature, it's called hyper feature. So you have hyper copy, hyper clone, hyper replication, hyper snap. All these are hyper feature. Okay. So what's the difference between smart and hyper? Smart basically is to, we can say that basically is to improve, okay, or increase your storage utilization or performance. Okay, improve or increase, okay, your storage utilization. Okay, or performance. Okay, or performance. That's basically the smart function. Okay. Okay, how about hyper series? So you have hyper snap, hyper copy, hyper clone, hyper replication. So from the name, you know that this is basically for data protection. Okay. So basically, whenever you see hyper snap, hyper clone, hyper copy, is to protect your data itself. So that is the series of the software that used for data protection. Okay, we call it hyper series. So you have all those hyper things. All these are there for data protection. Smart. Okay, all these smart feature here is basically is to improve your storage utilization or performance itself. Right? So all these are the smart feature. So basically, these are the 2 software Huawei offer. Okay, either you call it a smart feature or you call it hyper feature only. Okay, there's no another name for it. Okay, there's no another name for it. Okay, so we will look into these 6 only, not all of them. This is just some of it. It's not everything. This is some of it. So we just look into these 6. First, we look into smart team. Okay, smart team. So smart team is basically a license or a software in order for you to create a team LAN. Yes, Bolaji.
Thank you, sir. When you mentioned the smart, while you tried to define the smart, you said it improve or increase storage utilization. The word utilization, I observed that we've been dwelling more on storage utilization. I was thinking about CPU utilization, sir. Is it not linked together? CPU utilization, storage utilization. I was thinking they collaborate, they work hand in hand.
No. When you're talking about CPU, you're talking about server CPU or you're talking about controller CPU?
Yes, server CPU.
No.
Okay.
This is storage itself, storage alone. Okay, storage alone. Okay, we look into team provisioning. So smart team basically is to enable you to create team LAN. That is the function of the smart team. Okay, is for you to create a team LAN. Without this license, without this smart team license, you cannot create a team LAN. Okay, so what is a team LAN? So we mentioned grain is to create team LAN. Okay, extend is to create team LAN. So now we will see what do you mean by team LAN. Okay, what do you mean by team LAN and TIC LAN? Okay, so first of all, you need to know how the TIC LAN works. Okay, how the TIC LAN works. So let's say that, okay, I go back to the whiteboard. Okay, so in a TIC LAN, let's say that right now in my storage pool, okay, I have 10 terabyte in my storage pool. From the storage pool, I create 3 LAN. 1, 2, 3. I create 3 LAN. Right? So let's say this is my LAN 1, LAN 2, LAN 3. I create 3 LAN. Okay? Then this 3 LAN, the size of this 3 LAN, let's say the LAN number 1 is equals to 1 terabyte. Okay. Okay. Number 2, the size is equals to, let's say, 2 terabyte. Okay. Then LUN number 3, the size is equals to 2 terabyte. Okay, 2 terabyte. Okay, this is the storage size. Then out of the 1 terabyte, I use maybe around 500 GB. Okay, I only use 500 GB for the first LUN. For LUN 1, LUN 2, I only use maybe 100 GB. For LUN 3, I use, let's say, 1 terabyte. Okay? So basically, this is the size of your hard disk. This is out of the size. How many have you used? The disk itself. Okay? So right now, we have this scenario over here. So what is the difference between thick and thin LUN? Okay? So let's say that all this LUN, LUN 1, LUN 2, LUN 3, is a thick LUN. Okay? It's a thick LUN. So your storage pool have 10 terabyte. I create 3 LUN. Each of them is 1 terabyte, 2 terabyte. So basically, total is 5 terabyte in size, but I only use 1.6 terabyte. Okay? How many storage space I will use from the storage pool? Okay? So if you are using a thick LUN, okay, if you are using a thick LUN, so basically, out of the 10 terabyte, you need to minus out basically all the size you already reserved. So you need to minus out 5 terabyte. Okay, so if you are using thick LUN, the storage pool will reserve 5 terabyte for you, because this is basically the total size of each and every one of the LUN here. Okay, so from 10 terabyte, I will reserve 5 terabyte for you. Okay, this is for thick LUN. How about if let's say that this LUN, I change it from thick LUN, I change it into thin LUN. Okay, so in this case, thin LUN, how many space I will allocate from the storage pool? Okay, will you locate 5 terabyte, or will you locate just whatever that I used? The answer is you just will allocate whatever that you have used only. Okay, so from the 10 terabyte, whatever you have used, 1.6 terabyte, if it's a thin LUN, all these things, you only will get 1.6 terabyte. If it's a thick LUN, I don't care you use how many GB or TB, I will allocate everything for you. What do you mean by allocate? Means that it's reserved for you already. Other people cannot use it. Okay? So this is the difference between thick and thin LUN. Okay? Thick and thin LUN. Okay, so basically you will see here, okay, from this example over here, that's my annotation. Oops, sorry. Okay, from this example over here, okay, you will see that the first thing over here is that thick LUN, okay, let's say that the first disk is 7 terabyte, the second disk is 6 terabyte, and the last disk is 7 terabyte. But I only use 6 terabyte, 4 terabyte, and 5 terabyte. So I only use around 15 terabyte. Okay, I only use 15 terabyte, but I will still allocate 21 terabyte for you because you are thick LUN. I don't care you use how many percent. I will allocate everything to you. I will allocate 7 TB for this LUN, 6 TB for this LUN, 7 TB for another LUN. Okay, I will allocate everything for you. So you see that the allocate size is 21 terabyte. You use 7 plus 7 plus 6, you will get 21. Okay? Okay. Sorry, this is 8 terabyte. Okay, this is 7, this is 6. So you get 21 terabyte. Okay, for thin LUN, you will see I only will allocate 15 terabyte only. Okay, you use how many? 6 plus 4 plus 5. I only will allocate 15 terabyte from you from the storage system. But the user, okay, can see the whole size itself. So I can see 7 terabyte here. I can see 2 terabyte here. I can see 7 terabyte here. Sorry, this is 8 terabyte. I can see 6 terabyte here. I can see 7 terabyte here. But the actual consumption, you only will consume 6, 4, and 5. So in this case, I only will allocate whatever that you consume only. Right? That is basically the difference between thin and the thick LUN. Okay? Okay, so key LAN is a logical disk accessible by host. You can mount this disk to a host as a LAN. Here is a thin LAN. So it refers as a thin LAN, and the storage space are dynamically allocated from the storage pool based on actual user storage capacity in use. So how many you use, that's how many I will allocate to you. So if you never use it, I will never allocate to you. Okay, but you can see the whole size. So that means that if let's say that I create a LAN, okay, I create a LAN. Let's say that this LAN is actually a 10 terabyte of LAN. When you mount to the server, you will see a full 10 terabyte hard disk over there. But this terabyte hard disk is still not yet allocated to you yet the space. Okay? So basically, I just use, let's say that this is 4 terabyte. I just use 4 terabyte. You can see the whole 10 terabyte, you only use 4 terabyte, the storage will only allocate 4 terabyte for you. So that's why over here it says actual capacity consumed by data. That is how much you allocate from the storage system. The rest 6 terabyte is visible, but I still not yet allocate to you. Okay? So that is basically the thin LAN function. Okay? The thin LAN is the difference between thin and the thick LAN. So in what scenario, okay? In what scenario you might use, okay, later we'll explain. So what is the function of the smart thin? So basically the function of the smart thin, the software itself, is to allow you to create thin LAN. That is basically the function, okay, of the smart thin. Okay, so that's basically the function. So basically this is basically tell you that allow you to create thin LAN. And the support allocate on write means that you need the capacity, I only will give you the space. If you don't need it, then I will put it in my storage so I can allocate to other people. Okay, so I don't reserve it for you. Okay, thin LAN also support online expansion. So there's 2 types of online expansion. It can be indirect storage expansion or direct storage pool expansion on the thin itself. Okay, so what do you mean by that? Okay, what do you mean by these 2 things over here? So let me go back to the whiteboard. Okay, so what do you mean by indirect storage expansion? Okay, indirect. So indirect is basically is like this. Okay, so let's say that right now my storage pool, I have, let's say, 2 terabyte of space in the storage pool. Okay, when I create the LAN, okay, when I create the LAN, when I create this LAN, I can create the size bigger than my storage pool. It means that I can create more than what I have, okay, in a thin LAN. So in this case, let's say that I create a size of the LAN itself is equals to 5 terabyte. So in thin LAN, you can do that. The LAN that you created can be more than what you have. But thick LAN, you cannot do that. How many you have, that's how many you can create. But in thin LAN, I can create more than that. Okay? So when you create more than that, means that you over-promise what you have. So the indirect expansion means that you create a bigger LAN over here, you expand the storage pool over here. So 2 terabyte not enough, I plus another, okay, I add another 3 terabyte, I expand it. So you expand the storage pool without touching the LAN size, without touching this LAN size. This is what we call it as an indirect expansion, right? So this is what we call it as a indirect, okay, indirect expand. Okay, expand. Okay, indirect expand. Okay, so this is called indirect expand. So you don't touch your LAN. Your 5 terabyte is still you still maintain, but you extend your storage pool. We call it as indirect expand. Okay. So direct expand basically is that 5 terabyte not enough. I plus the LAN size from 5 terabyte. I add another few more terabyte to it. Let's say that I add another 2 terabyte to this. So in this case, your LAN will become 7 terabyte. So this is what we call it as a direct expand. Okay, direct expand. So that's the difference between the indirect expand and the direct expand part. So either you expand on the storage pool or you extend the LAN size itself. And that's where you differentiate. Both of these features, they support online. That means that you don't need to shut down or disconnect your storage from the system. So they do support online expansion. Okay, online expansion. Okay, all of them support online expansion. Means that you don't need to shut down your storage, you don't need to shut down your server. You can expand it on the spot. Okay, on hot or on the spot itself. Okay, so this is basically the thin LAN and the thick LAN that they want to explain over there. Okay, so basically this is the online expansion, indirect, and the direct storage expansion, okay, that we talk about here. Okay, then thin LAN support two types of space reclamation. Okay, so basically it's a standard SCSI space reclamation and zero data space reclamation. Okay, so why do they have this kind of space reclamation? Okay, because thin LAN is only allocate what you use. Okay, for example, right now I use 1 terabyte from the space. So the thin LAN allocate 1 terabyte to me. Then after that, tomorrow, I delete out of the 1 terabyte, I delete 500 GB of data. So when you delete the data, means that your actual usage is only 500 GB. How about the 500 GB that I already allocate to you previously? So when you delete the data, you need to give back the space to the storage system. So the storage system need to reclaim back the storage space that's unused. Okay, so that's why you have the space reclamation type of function. Okay, where thick LAN, they do not have this kind of thing. Okay, your thick LAN are already reserved to you. You use it or you don't use it, that's your business. But in thin LAN, if you don't use it, you need to return back to me. So I need to reclaim back whatever space that you do not need to use it. Okay, so that is basically what the smart team can do. Okay, so this is just talking about the virtualization and nothing important. Okay, so thin LAN, okay, how do you allocate space on the thin LAN and how do you direct the LAN to write on the storage pool itself? Okay, so there's two mechanisms that function in the thin LAN to do the location. Okay, to do the location. The first one is called capacity on write. The second one is called direct on time. These two guys over here. Okay, direct on time, capacity on write. Okay, so the problem is which one comes first? Okay, which one comes first? So always the direct on time comes first. So how does it work? So let's say that right now, okay, right now, you imagine this LAN, this computer is actually a LAN. Okay, this computer, you mounted a LAN. Okay, you mounted a LAN over here. You mount a LAN. Okay, and this LAN size, let's say that the size is equals to 100 GB. Okay, but I only use, let's say that I only use 10 GB. Okay, so in this case, only will allocate 10 GB to you. Okay? Okay, then this computer or this one, you want to add more data. So I want to add more data here. So another 2 GB to you. So in this case, the first thing you will do, you will direct this 2 GB to the thin LAN. Then the thin LAN will say that, okay, do I have the space or not to write the new 2 GB? Okay, so if let's say that this 2 GB is meant to replace, let's say that it's meant to.
Yes, Ademola.
I wanted to tell you to mute everybody. Some people are disturbing us.
Okay, I've done that. Thank you.
Replace some data in this 10 GB. Means that if you want to overwrite the data, so that the space is already allocated because you want to overwrite the data of it. So if you want to overwrite from the 10 GB here, means that the space is already allocated. So if it's already allocated, I will direct you to the actual hard disk to write the data into it. Okay, so if it's already allocated, and then I will direct you to the actual hard disk and write on the hard disk space itself. If this 2 GB is a new data, not from this 10 GB itself. I don't want to overwrite the 10 GB. It's a new 2 GB data itself. So in this case, the space is still not yet allocated to you. So return to 0. So if you would say that, oh, I want to write into it, they say that, okay, there's no space that allocate for this 2 GB. So I need to ask from the storage pool to get the 2 GB to me first. So I need to allocate first, and if it's not allocated, so allocate first, if not, allocate. So who is the one that doing the allocation? Not direct on time do the allocation. Direct on time basically is to guide you to the storage space to write on it only. So who is the one that give you the additional space? That is basically the capacity on write. he will give you the new storage space itself. So let's say that right now I have 2 new GB. I do not have a new space. So ThinLAN need to add additional 2 GB for it. So I will get the storage from the storage pool, add 2 GB, allocate the 2 GB to the ThinLAN.
Please attention everyone. I would like you all not highlight some things. There's a need for me to let you know. Now this, please take notes. You'll be asked in an exam that's cow. You will see something like cow. So it is not cow for the normal cow, because many a times in our way we use acronyms. So it is capacity on write or copy on write. Ahmed asked me similar question now, but I'm going to answer later on. We have copy on write and we have capacity on write. So they still mean the same thing. So let's continue with the class. So please take note of this COW. Yes, Mohammed Dafala from Sudan. Quickly. Quickly. You can speak. Mohammed, I can hear you. Mohammed, are you there? Mohammed, are you there? Okay, Ademola, speak. Ademola, can you speak? No, I've muted everybody anyway. Okay. So, yes, Ademola.
Yes, sir. Okay, sir. Now, I want to get the concept of capacity on write and that direct on write. He said the direct online only directs you to where it will do the work that it's not the one doing whatever allocation that wants to be done in the storage, right?
For now, I don't want to answer any question for now. I want us to, so that we don't mix the information together. So I just want us to finish this slide. When we finish this slide, then we will introduce ourselves to question and answer section, because by the time I now contribute my own, it might at the end of the day want to look confusing. So I don't want to distract you in any way. So absorb the information from him first, then at the end of the class, then we interact. How is that? Is that not okay?
Okay, no problem, sir.
Well, thank you for understanding. Sir. Thank you. So, Mohammed, are you still there? Mohammed. Okay, please let's keep all the questions to interactive. Just note it in your notes. We will interact. We will still interact. Trust me on that. Please, let's continue this lecture so that we don't miss out. Please. Thank you.
So this is what we call it as a capacity on write. I allocate to you, then you write on it, right? So after I allocate to you, then I will direct you back to the space that I allocate to you to write into the space itself. So actually these two mechanisms, direct on time and capacity on write, work together. Okay, work together. So if the space is already allocated to you, I just need to direct you to that place. If the space is not allocated to you yet, then I need to give you a capacity on write. I need to give you a new capacity, then I will direct you to the new capacity and write it there. Okay? So that's how these two mechanisms work in the smart team. Right? In the smart team. So these two mechanisms is interrelate to one another. Okay? Interrelate to one another. Okay? So these are the two mechanisms, direct on time and capacity on write. Right? These two are the mechanisms. Okay, so in what scenario you can use ThinLAN? Okay, so you can use it for a business that has high requirement for business continuity. So using a smart team allows you to perform online expansion of the system without interrupting the business service. For example, bank transaction system. Okay, you can create as a thin LAN because they support online expansion. Okay, actually, not only thin LAN support online expansion, your thick LAN, they do support online expansion as well. Okay, so actually, this is not really the main type of benefit compared with thick LAN. Okay, but thin LAN, they can do it. Thick LAN also can do it. Okay. Second type of application scenario is that for business that have high application data growth that you cannot determine how much space you need. You cannot accurately determine the how many space you need. Then you can use Smart Thin to allow the system on demand to allocate the storage space to you. Okay? So use Smart Thin configuration allow on demand allocation of physical storage space and avoid wastage in utilization rate. Okay? For example, email service or web service. So all these kind of application where you cannot determine every day what is a trend, how many GB you need per day. So in this case, you can make it into a thin LAN. So if you need, you request from the system. If you don't need it, then other application can use that space itself. So you have a better utilization, space utilization. Okay, last kind of application scenario will be for business with complex system and has different requirement for storage for different services and applications. So use Smart Thin configuration allow different business service to compete for the physical storage space. So allow optimum configuration for physical storage space itself. So for example, carrier service provider. So I have only this limited resource. I only have this limited resource. So you can create how many LAN you want. But the problem is all these are coming in from the same resource itself. So they can compete between one another, first come, first serve. So whoever you first, I will give you the space. If you don't need the space, you give it back. I can serve for another customer. So in this kind of scenario, you can use a thin LAN. Okay? So this is basically the thin LAN scenario itself. Okay? So the configuration process, I'll teach you later. It's very simple. Okay? So that's all for thin LAN. So in conclusion, we can conclude that thin LAN, you are able to over-promise what you have. Okay? You can over-provision, we call it over-provision what you have. Okay? But the good thing is that you need it, you use it. You don't need it, you give it back. But the bad thing is that the engineer, the storage engineer needs to constantly monitor the utilization because you can overpromise. Yeah? Your storage pool is 10 terabyte. I can give you 100 terabyte LAN. There's no problem on that one. But the problem is after 10 terabyte, the 100 terabyte no longer can write it because no longer have physical space. So the storage engineer need to monitor the utilization. So there's more job for the storage engineer to do. Okay? Compared to thick LAN, okay, storage engineer just create to you. I need to monitor it because whatever you have, that's whatever that I have. So I cannot over provision to you. Alright? So that is basically the summary of the Smart Thin. Okay, anyone have any question for Smart Thin? Okay, so Smart Thin is basically a software that enable you to create a thin LAN only. That's all. Okay. Yes, Saya.
Can you come again with the Smart Thin? Yes.
Smart Thin?
Smart Thin.
I haven't gone into Smart Thin yet.
Just give me 2 minutes. I want to see my document.
So I'm still asking Smart Thin. Anyone have a question for Smart Thin? Okay, so if no question, then we go for Smart Thin. Okay, Smart Thin. So what is the function of the Smart Thin? So the function of the Smart Thin is basically to perform data relocation. Okay, is to perform, we call it migration or relocation. That depends on what name you want to call it. So you can perform data relocation. Okay. Okay, so in what scenario you can use a Smart Thin? Okay, you can only use Smart Thin if let's say that your storage pool or your disk domain have more than one type of hard disk. Okay, if it's only one single type of hard disk, you cannot use Smart Thin. If you have more than one type of hard disk, then you can use Smart Thin. Okay, so this is the prerequisite requirement. You need to have multiple type of disk in the either is in the disk domain or in the storage pool. Then only you can use the Smart Thin feature. Right? Smart Thin feature. Okay, so how does this Smart Thin feature work? Okay, so when you create the LAN, when you create your LAN, your LAN will get from a lot of places, right? If let's say that this is a hybrid. You combine 3 disk type into it. So I combine an SSD. Okay, so let's say that this is my LAN. Okay, this is my LAN. So let's say that you combine some SSD over here. Okay. So let's say that your LAN here, a little bit come from SSD, a little bit come from SAS, a little bit come from the nearline SAS. Okay, because you combine use. Okay, your LAN create from multiple type of these. Okay, nearline SAS itself. So when your storage, when the application want to write the data, when you want to write the data into the LAN, right, because you have these 3 type of these, which type of this you will use first? That is the question. Okay, which type of these you will use first? So if you don't configure smart here, they will just randomly, whichever type of hard disk you have a space, I will just write it inside. Okay, so I will just write every one of it. Okay, and I don't care what type of disk, I just write it inside it. Okay. But the problem is not every data is the data that you always use. So in this case, we separate the data into 3 types. You have hot data, warm data, and cold data. Okay, so basically this is to determine how frequent you use the data. So the more frequent you use the data, then the higher the data itself. So basically higher the temperature. So the hot data means that you every day use, maybe every hour you use it, we consider as hot data. Warm data, maybe once a week you use it. Cold data, once a month you only access it. Those are cold data. So if you don't classify which type of disk you use to store the data, whatever data I come in, I just randomly put inside here. So you will see that in the SSD, SSD is very fast. It's a high performance disk itself. But some data in here is a cold data. Means that you don't always access it, but you put it into the SSD capacity. Right? Then in the SAS, there's some hot data you put into SAS as well as the nearline SAS. So when the hot data means that every day you use is located in other than SSD, basically your read speed is slower because compare SSD SAS and nearline SAS, SSD has the highest input-output per second. All right. So SAS, nearline SAS will have the lowest. So if you have some data here is stored in the nearline SAS, so that means that when you want to read this data, it's going to take longer time for you to load the data up. Okay. So you do not have a very good experience. Okay. Or you do not have a very good latency time, very low latency time. Okay. When you want to read this data over here. Okay, so to migrate this kind of data, let's say that you already put it into the hot data, already put into the into the nearline SAS. So how do you migrate? You can't migrate, okay, by default. You have to use the smart tier to do the migration. So you will see when you enable the smart tier, he will perform the data relocation. So he will determine all the hot data, everything put into the SSD. All the warm data, all put into the SAS. All the cold data, everything put into the nearline SAS. Okay, they will do the relocation to you. So that is the main function of the smart tier, doing the relocation. Okay, doing the relocation. Okay, so in this case, in smart tier, they divide your disk into 3 because you have 3 types of disk: SSD, SAS, and nearline SAS. So they call it high performance, performance, and capacity. So that's how they differentiate them only. Okay, SSD, SAS, and nearline SAS. Okay, so how is the working principle work? Okay, so let's say that at initial, all the data is written into the SAS. Okay, everything is written to the SAS. Let's say this is your configuration. Write all the data into the SAS first. So he will write every data into the SAS. Okay, then they will do basically they will do what we call it as a checking, and not really checking, basically it's monitoring. Okay, so you write, let's say that there's 6 data here, A1 to A6, 6 data here. Okay, so when you write into it, then the system will start to monitor what type of performance or what type of movement you have done on these 6 data. Are you frequently read or you don't read it at all? All right, so there's a monitoring. So you will monitor all this data, how frequent you use it. So the question is, when you want to monitor how frequent you use this data, where do you monitor it? So you must have a place to monitor it. So who is the one that's going to process your input and the output? Okay, the answer will be your controller. So you monitor at the storage controller, because whatever data in and out, it will be recorded in the controller. So controller will know this 6 data, which data you most frequent process. So you process more of this data means that the more you use it. We categorize as hot data. Okay, so you will monitor it at the controller itself. Okay, so let's say that you've written this 6 data, I monitor this 6 data. Then I found out A1 and A2, these 2 data, you every day, you always use it. A5 and A6, you never use it before. Once you put it inside, you never use it before. A3 and A4, maybe you use it 1 or 2 times only. So I monitor, I will get a summary. Right? I will determine which one will be hot, warm, and cold. After you determine hot, warm, and cold, then they'll perform the relocation. So all the hot data go into the SSD. All the warm data stay here. All the cold data move into the nearline SAS. So they will do the relocation. Basically, it's like a migration itself, the data block migration. All right? So then you relocate. Then the next state, you put in more data inside. So all of them put into the performance. Then again, he will monitor all the data, how frequent you use the data from the controller, in and out from the controller. Then after that, I will determine again which one is a warm data, which one is a cold data. So you see that A3 and A4, let's say that this is Monday. Monday, he determined this is a warm data. But let's say Tuesday, every day every hour you also use this data. So you'll become a hot data over here. You see that? From warm data, you'll become hot data. Okay? So basically, he will monitor each and every one of you data here, because today your data might be cold data, tomorrow this one might be hot data already. So they will monitor everyone, then they will relocate accordingly to how frequent you access from the storage itself. So the more frequent, you go higher. The less frequent, then you go to the capacity. Okay? So this is how the working principle of the smart tier itself. Okay? Okay, so there's a few key technology you need to know inside the smart tier. First of all will be the initial capacity allocation. So what does it mean? So this means that when you want to store your data into this LAN, let's say that your LAN have SSD, SAS, and nearline SAS extend. You have these 3 extend over here. Which type of extend you will choose first? Okay, that is basically talking about here. Initial capacity allocation. Okay, so this is basically the system will write the data into what type of hard disk in the LAN itself. Okay? Either you write into SSD, SAS, or nearline SAS. Okay, so they have these 4 type of policy you can choose from. So you can automatically allocate, priority allocate to high performance tier, priority allocate to performance tier, or priority allocate to capacity tier. So these are the 4 type of initial capacity allocation policy that you can choose. Right, so this is the first key technology. Second key technology will be setting the migration policy. So this one, the migration here from the SAS, you want to migrate to the nearline SAS, there's a migration policy. So it means that you can make it into automated or you can make it into a manual. It depends on you. So these are the 4 type of policy you can choose from the migration policy. Automatic migration, migrate towards performance, towards high performance tier, migrate towards low performance tier, or no migration. Okay, so these are the policy that you can choose. The third key technology will be monitoring and analysis. So this is basically to activate the monitoring itself. So I can record down which data you more frequent access, which data you don't access at all. So this is basically the monitoring and analysis itself. So you need to activate this I/O monitoring to analyze the data. Okay, to identify the data to be migrated. So basically, you will generate a report to tell the storage which data is hot, warm, and cold. Then the smart tier will migrate the data accordingly. What that the analysis that give it. Right? So you need to activate these services, monitoring services. Okay, last we'll be talking about migration, data migration. So in here you can do it. You can create a migration plan. What day you want to perform a migration. Okay? Or you want to make it into a periodic, every Monday, every Friday, do a migration. Okay? You can make it as a plan. Okay? And other than that, you can also change the migration rate, means that the speed of migration. So you can change the speed, low, medium, high. Okay? The speed to perform the migration. Then lastly will be the data migration granularity. Okay, this data migration granularity, you cannot change in the smart tier. Then the problem is, what is the size? Who will it follow? It will follow your extent size. Okay, so the data migration granularity is equals to your extent size. Okay, is equals to your extent size. So if your extent size is 4 megabyte, then basically your data migration granularity is 4 megabyte. So this one you cannot change in the smart tier because you can only change it when you create the storage pool. That's the only place. So your storage pool will also affect the smart tier migration, the extent size itself. Okay, so this is your extent size. Okay, so these are the 4 key technology. So we look into one by one. First of all, we are talking about initial capacity allocation. Okay, so initial capacity allocation means that this one, you have 3 types of this. Which type of this you will use first? Okay, is this a nearline SAS? Is it a SAS or is it SSD? Okay, so they have 4 types of initial capacity allocation policy you can choose from. Okay, the first one is called automatic allocation. Okay, so let me just put in the whiteboard. Good. Okay, so the first type of allocation, okay, is called automatic allocation. Okay, so in automatic allocation, which type of this you will use first? So basically, you will choose the SAS first. Always go for the SAS first. Okay, if SAS is finished, then only you will use the nearline SAS. Then in the end, you only will select SSD. So this is what you mean by automatic allocation. Means that when you want to write the data into this line, you always will write it to SAS extent first. If all the SAS extent is full, then only you go to nearline SAS. If SAS and nearline SAS all is gone, then only you will choose for the SSD. So this is what we call as a automatic allocation. Okay, automatic allocation. Okay, so second type of allocation is that allocate to high performance tier. Okay, allocate to high performance tier. So in this case, what type of hard disk you will choose first? Okay, what type of hard disk you will choose first? Okay, so as the name said, it's a high performance tier, means that the first disk you will select always go for SSD. Then after that, only go for SAS. Then in the end, you only will go for nearline SAS. So this is allocate to high performance tier. So if you select, the policy is allocate to high performance tier. This is the flow. Who will use first? Okay, then the third one is allocate to performance tier. So allocate to performance tier is the same as automatic allocation. So this is also, we call it as allocate to performance tier. Okay, it's the same. How you arrange SAS, nearline SAS, SSD. So these two are the same. This is basically SSD, SAS, nearline SAS. Then the last one is allocate to capacity tier. Okay, allocate to capacity tier. So if you allocate to capacity tier, the first disk you will select always will go for nearline SAS. So if your nearline SAS is finished, then you go for SAS. If your SAS is finished, then in the end, you only will go for SSD. So these are the four type of capacity allocation that you have. So you can select from any one of these policy. Okay, any one of these policy. So this sequence you have to remember. Okay, this sequence you have to remember. Okay, so this is the sequence itself. Okay, go back to this. Okay, so this is the initial capacity allocation. So you have these four over here. Okay. Okay, next we look into migration policy. Okay, migration policy. So in migration policy, you have 4. Okay, forgot to mention. Okay, initial capacity allocation. Okay, what is the default policy you will use? So the default policy you will use will be automatic allocation. That is the default policy that you will use. Okay, so next we go into the migration policy. So migration policy, we have 4. No migration, migrate to a higher performance tier, migrate towards lower performance tier, or automatic migration. These 4 of them. So basically, what's the difference? First, No migration, actually, okay, no migration means that he will not perform any automatic migration. So this is also another meaning called as a manual migration. So you have to manually activate the migration yourself. So that's what you mean by no migration, right? Manual migration. Okay, then these two, migrate towards high performance tier, migrate to a low performance tier, and automatic migration. So what's the difference between these three? Okay? Automatic migration, okay, we talk about automatic migration first. So automatic migration, he will migrate your data based on the statistic or based on the result. Okay, basically, if it's a hot data, go to SSD. If it's a warm data, go to SAS. If it's a cold data, go to nearline SAS. So he will accordingly migrate your data based on the activities. Okay? Based on the activity that you label him as what? As a hot, warm, or cold. Then you use the migrate data, this one. Okay, let me change the text words. Okay, so this is migrate data based on your usage. Okay, or based on the usage, to say. Okay, so basically based on the usage or based on the result. Okay, result from the monitoring. IO monitoring. Okay, so this is basically automatic migration. So the accordingly, hot, warm, cold, accordingly to migrate. Okay. Okay, then go back to here. Migrate to a high performance tier and lower performance tier. So this one is I don't care about the result. Okay, the result. So let me say I don't care. You are warm, hot, or cold data. Always they will migrate everything to SSD. If your SSD is done, okay, I don't care about result, or migrate to SSD. So if your SSD is not enough, then only it will go to SAS. Okay, then only it will go to nearline SAS. Okay, so this is basically the migrate towards high performance tier. You don't care about the result. You don't care about the monitoring. I don't care if you're hot, warm, cold, or go up. Right? Or go to SSD. If SSD is finished, or go to SAS. Okay, so this is basically migrate towards high performance tier. This one, migrate towards lower performance tier, is the same thing. Don't care. Okay, do not care. Don't care about the result. Okay, or migrate down. Okay, or migrate to nearline SAS. If nearline SAS is done, then you migrate to SAS. Then in the end, you migrate to SSD. Okay, so you don't care about the result. So everything go down. I don't care. You're hot, warm, cold. Go to nearline SAS. Okay, as long as nearline SAS has space. So these are the 4 migration policy you can select from. So which one is the default migration policy? The default is this one, no migration. So if you will not help you perform any migration, you have to perform it manually. That is the default policy. So if you want to change it, you can change it any of these 3. Right? So this is migration policy we talk about. Okay, next, IO monitoring and analysis. So if you want to use this one, automatic migration, you need to activate the IO monitoring because I need to have the result. I need to know which is hot, warm, and cold data. Okay, so you activate it, then you will monitor it on the controller itself. Okay, then he will tell you the result, who is a warm, hot, and cold data. Yes. Okay, do you have a question, Afi? Hello, Afi, you have a question? Hello, hello. Okay. So in this case, I'll just go on first. Okay, so this is the monitoring. So this is basically to determine
hello,
hot, warm, and cold data. Yeah,
hello, Roy, can you hear me? Okay,
Yeah.
I want to ask, when you talked about initial capacity allocation, you talked about the default policy. What did you call the default policy for initial capacity allocation?
Default policy that he will use will be automatic allocation.
Okay, all right.
Okay.
Thank you.
Yeah. Okay, so back to here, our monitoring. So this is basically to monitor your input from the controller, in and out from the controller to determine hot, warm, and cold data. Okay, then what happens if let's say that you have more than one controller, not only one single controller, because monitor, they only monitor one controller. So let's say that right now I have 3 controllers over here. So how do they do the monitoring? Because different controller, you have input and output from differently. and the data will be different. So in this case, if it's in a multi-controller environment, Smart Tier will link all the controller together for a unified data analysis. So you collect, controller 0 collect, controller 1 collect, controller 2 collect, then Smart Tier will collect everyone, then do a summary. Okay, based on all the data over here, we will determine which one is hot, warm, cold. So it will not determine individually already. You will determine by everyone, with everyone together. Okay, so they will unify the data to analyze, to determine the data activity. Okay, so this is what you will do when you have multi-controller. Okay, so let's say that in multi-controller environment, okay, one higher level problem is that each controller, you have different type of hard disk. For example, controller 0, you only have SSD. Controller 1, you have SAS and nearline SAS. Controller 2, you only have nearline SAS. If let's say that controller 2, whatever data that's stored in the controller 2, there is a hot data. Controller 2 can perform cross-controller migration into this controller to store the data into the SSD. Okay? So perform cross-controller data migration in the corresponding storage tier. So if let's say that this one have a cold data, you have to move the data either to controller 2 storage or controller 1 storage. Okay, if it's a warm data, all need to go to controller 1. So this is what happens if you have multi-controller plus different controller have different type of hard disk that you control. And then you will perform cross-controller migration plus cross-controller analyze among all the controller data. Okay? So this one will be the I/O monitoring part. Okay, so this is basically just to tell you, the more you use your storage, the lower your total cost of ownership because you better utilize your device only. Okay, so this is not really important. Okay, so basically that's all for Smart Tier. So in the end, we can conclude Smart Tier is just a software enable you to perform data migration between hard disks. Okay, when you create the LAN from different type of hard disks to migrate within the same the LAN itself, migrate inside itself, okay, to different type of extent. So that is basically the function of the Smart Tier. Okay, okay, so that's all for Smart Tier. Anyone have any question regarding Smart Tier? Anyone have any question?
Hi, hello.
Yes,
it seems today I'm really having a problem with my internet here. Yeah. I left off when we were talking about data migration. Is it possible you can just brief from there?
This part?
Short brief.
This one?
Yes.
Yeah. Okay, so this one in what scenario? When you have multi-controller scenario. So all the controllers have their own input, output, right? So how do I consolidate all the data to determine hot, warm, and cold? So if you have multi-controller, all the data will be created at one pile, then they will analyze together to determine all the data that's stored between these 3 controllers, who is a hot, warm, and cold. Okay, this is the first scenario. Let's say that you have multi-controller, then after that, each controller, they control different type of hard disks. For example, controller 0, they only have SSD. So if whatever data in controller 0 is not a hot data, you need to migrate into another controller. So in Smart Tier, they do support cross-controller migration. You migrate your data from SSD into the SAS is here. Okay, you see that migration. That's what you're talking about. Okay.
All right. Right.
Yeah. So anyone have any other questions for Smart Tier? Okay. No question, huh? Okay. Okay. So if no question, then okay, it's almost 7. Okay. So today I still do not have enough time to finish up for the lab. Okay, I still have 1, 2, 3 more chapters over here. So it's quite a lot. Okay, so let me see the result. Okay, so I see that 4% are agree on Monday, Saturday. Yeah, who is it? Bolaji?
Bolaji, yes. Yes, I just have a quick suggestion. So is there a way you could just, in maybe the next 10 minutes, let's brush the lab, maybe the setup and everything.
You can base on the lab guide and do the lab. Okay, you can base on the lab guide to do until Smart T. Okay, to do until Smart T. This one.
Okay.
Over here. Okay, you can base on the lab guide. The lab guide actually teach you everything. Okay. If you want to do it yourself, you can use the lab guide as a guide. If you want to wait for me, then tomorrow I will do the lab review guide. Okay. Tomorrow I'll do the lab.
Hello, Roy.
Yeah.
Yes, concerning the, for us to indicate for the extra lecture, I think many of us have indicated on the WhatsApp group. So you can use that as
Saturday.
well.
I see on Saturday. Yeah. A lot of people are looking on Saturday.
Yeah.
So majority is on Saturday. So let us put it on Saturday. Okay.
Oh,
Let's put it on Saturday.
thank you. That's good enough.
Yeah. So for those unable to attend, sorry because majority they want to go on Saturday. Okay. So I can't open 2 class on Saturday and Monday. So we only will go for Saturday. Okay. So Saturday we'll have an additional class for it. Okay.